Hello, welcome to homework video 4.05, which is all about compound inequalities. So let's take a look here. Write a compound inequality to describe each number line below. So when we have the arrows going in two separate directions, that's our OR situation. So really all we have to do is just kind of deal with them one at a time. If we look at this one, we've got an open circle on 8 and then an arrow off to the left. So this would be x is less than 8. Where we have this gap, that's where we throw in the word or. So it's x is less than 8, or, then if we look at this one, we've got a closed circle on 12, and then an arrow off to the right. So that's going to be or x is greater than or equal to 12. All right, so that's one example of a compound inequality. 2 is a little different, because now we don't have them going in opposite directions. We kind of have two endpoints, and our line is in the middle. So the way these work is we've got a negative 10 where one of our dots is, so we'll put a negative 10 down. We've got a 0 where our other circle is, so we'll put a 0 here. The shading's in the middle, so then our x is going to go in the middle. All right, so we've got a negative 10 on one side, a 0 on the other side. The x is in the middle. Question is, what needs to go right here? Well, x is less than 0, no equal sign, because it's an open circle, and it's greater than negative 10. Now, greater than, you might be thinking, oh, I got to make it like this, but it's actually x is greater than. So you can almost think of it as you're always making these less than signs. Even though this is saying, you've almost got to read this one backwards. This is saying x is greater than or equal to negative 10, and x is less than 0. So it's kind of doing both of those at once. I mean, kind of the short way, as long as you're putting the smaller number on the left-hand side and the larger number on the right-hand side, you're always going to be doing less thans. It's just a question of, do you need the equal sign or do you not need the equal sign? All right, so let's talk about actually solving these. When you're solving a compound inequality, you're basically just kind of doing two problems at once, and you're solving from the middle to both sides. So if we look at the middle here, we need that w by itself. So if we were looking at this problem, you tell me, oh, you subtract 2. If we were looking at this problem, you tell me, oh, you would subtract 2. We do the same thing, so we just do it to both sides at once. We subtract the 2, and then we're left with 1 is less than w, which is less than or equal to 5. Now, in a lot of ways, these are actually easier to graph, because we don't have to worry about which way our arrow goes. Let's just label some points here. There's 0, there's 1, 2, 3, 4, there's 5. Maybe throw a negative 1 there. 1, 2, 3, 4. Maybe throw a negative 5 there. So if we look at our line here, the 1 doesn't have the equal sign, so that's going to be an open circle. The one next to the 5 does have the equal sign, so that's going to be a closed circle. And then with these compound inequalities, with the letters falling in the middle there, we know we just have to basically connect our 2 points. All right, so if we were looking at this, 5 is part of our solution because it's shaded in. 1 is not part of our solution because it's an open circle. All right. Let's look at number 4 here. Again, the same thing. Just think of it as one problem and then just do the same thing to both sides. So I'm going to subtract 7, which means I'm also going to subtract 7 over here. So we end up with negative 9 is less than negative 3x, which is less than negative 3. All right, if you think about it as just one problem, your next step would be to divide by a negative 3. So we're going to divide by negative 3, but then we're also going to do it over here on the left-hand side. Now, the same rules apply. We divided by a negative, so these inequalities have to flip. This is going to become a positive 3 is greater than x, which is greater than a positive 1. All right, so you have to remember, just as before, like when you divide by a negative, those flip, and since we're dividing on both sides, both of them have to flip. So if we go over here to the graph, there's 0, there's 1, there's 2, there's 3, there's negative 1, there's negative 2, there's negative 3. All right. So both of these do not have an equal sign, so in both cases we're going to use open circles, open circle on 1, open circle on 3, And then even though we had to flip the inequalities, we still have the x in the middle here, so we're still just connecting our 2 points. All right, so it's just going to be kind of connecting the 0 and the 3 that way. You don't really have to worry about the arrows, which way they're going. You're just connecting the dots on these. All right, let's take a look at the back. Now the back is a little different. These are, instead of having the x in the middle, these are ors. So these are the ones where we're going to have the arrows going in opposite directions, and we basically just solve them one at a time. You know, we do this one first and say, all right, minus 5, 2d is less than or equal to negative 6. Divide by 2, divide by 2. D is less than or equal to negative 3. And then after we've done that, we just go and do this one. All right, subtract 5, subtract 5. Negative 2d is less than or equal to 0. Divide by negative 2, divide by negative 2. Even though the negative is not really going to change anything on this side, we still divided by a negative, so this becomes d is greater than or equal to 0. So we have these two different solutions. D is less than or equal to negative 3, or d is greater than or equal to 0. Both cases we have the equal sign, so we're going to need closed circles. Let's just get our labels here. There's 0, there's 3, there's negative 3. So since they're both equal signs, closed circle on negative 3, closed circle on positive 3. Now this one says d is less than or equal to negative 3, so that's off to the left. This one says d is greater than or equal to 0, so that's off to the right. And that's what you should expect on these. You should expect the arrows to be going in opposite directions. If you ever find a situation where you've got the arrows going in the same direction, probably means you made a mistake somewhere, so you should probably try to go back and find that. All right, let's try this one down here. Again, just solve them one at a time. Plus 3, 5x is greater than 10. Divide by 5, x is greater than 2. Go over and do the other one. Plus 6, 4x is less than negative 4. Divide by 4, x is less than negative 1. All right. Notice I didn't flip here because even though there was a negative, I was dividing by a positive, so it stayed a less than. So these are my two solutions. X is greater than 2, or x is less than negative 1. So let's just label some lines here. 0, 1, 2, negative 1, negative 2. I've got no equal signs here, so they're both going to be open circles. Open circle on 2, open circle on negative 1. This is x is greater than 2, so that's off to the right. This is x is less than negative 1, so that's off to the left. They're going in opposite directions, which is what I was expecting, so we're good to go. All right, last but not least, some translations. For each situation, write an inequality. All real numbers that are less than 3 or greater than 7. So this is going to be one of those situations where we just write two inequalities separated by the word or. That word or is kind of a real key for us. All right, all real numbers that are less than 3, so that's just going to be x less than 3, or x greater than 7. So I've just got two separate inequalities separated by the word or. All right, just like we had here. X is greater than 2 or x is less than negative 1. If we look at 8 here, all real numbers that are between negative 4 and 6. So instead of having the word or, we've got the word and, which tells us we're probably looking at one where the x is kind of falling in the middle. We've got negative 4 here, we've got 6 here, we've got x in the middle. Now a lot of times you'll see the word inclusive or exclusive. Inclusive means you include, so that's less than or equal to or greater than or equal to. Exclusive means you exclude, so that's just the less than or the greater than because you're excluding that number. Now when there is no word here, between is generally taken to mean exclusive, which means instead of using the equal sign, we're just going to use the regular inequality. So this is, and remember, on these I said, as long as you're putting the smaller number on the left-hand side, it's always just going to be less thans. As long as the smaller number is on the left-hand side, it's always going to be less thans. So here I have the smaller number on the left-hand side, So it's just going to be less than and less than. Okay? I hope this was some help. Have a good day.